Okay, got you in groups today to see if you remember old school quadratics. You remember how a quadratic equation looks kind of like this? And you have an equation like y equals negative 4.9 t squared plus 8t plus 3. And if you had that equation, it's the ACT test. They allow calculators. I'd like you to tell me the blue point right there. You should know that easily. This right here and this right here. But I don't want you to actually calculate all of them. One of them is just like, boom, you'll know the answer. And two of them, you'll get equations. You'll be like, oh yeah, we're supposed to use this equation. See if you remember what those are. And then last but not least, I'd like you to label the axes. Is this right here like the number of chickens? And is this like the number of eggs? Label the axes if this is about a ball being thrown in the air. This is the same problem we did. Remember walking in the parking lot and throwing the ball up in the air? That ring a bell? Okay. So do you remember what the X and what the Y was and how to find those 3 points? Pausing while you figured that out with your partner. Okay, let's see which things you have remembered. How many of you guys knew that this down on the bottom was time? Raise your hand if your group already had that. Excellent. And then this was the height. You don't have to raise hands on this one. And then last but not least, this one was 3. It was the starting height. When time was 0, put in a 0 here and here, you'd get y equals 3. The height equals 3. Does that all make sense to you so far? Okay, then what were the two big equations? I think I heard you say one of them.
Is it negative b over 2a?
You are correct. X equals negative b over 2a. One of the most forgotten little simple formulas for finding the vertex. And the y of it is f of negative b over 2a. That's to get the y of that point. So it's actually a point. You just stick that negative b over 2a into the function, and you can find the other part. Okay. And then here, L, what did you think this one was?
We just knew that we couldn't find it, but we knew that was where y equals 0.
I would agree that that's where y equals 0. So then you could put a 0 right here in this formula. And then what do you use to solve that, though? Because I'm giving you a hint. You can't factor it. So if you can factor it, you should. But what if you can't factor it? Do you remember? Do you remember? Yep.
No.
In the back.
The quadratic.
That is it. X equals negative b. Everybody write it down because you didn't remember it. Plus or minus the square root.
B squared minus 4ac all over 2a.
That is correct. I was expecting more people to forget the negative b over 2a, but I guess a lot of you forgot the quadratic formula. Probably the premier formula you've memorized. Probably the longest formula you've got in your head. It's got 16 parts to it. It's kind of impressive if you count every little character in it. X equals is 2 parts, you know. 16 total things you got to know. All right, so anyway, now every little character counts as so there's 16 little parts. All right, so my point here is to remind you about X and Y, and we knew at any given moment, let's say I make a red dot right there. What do we know about it? We know its height, and we know the time it's at that height. Is there anything else you could know about the ball? You could know the velocity. Does anybody remember where that is? I see it. It's on the screen right now. Lots of weakness and recall of these things. This is scary. The velocity of the ball. Yes. 8. Yes, it's right here. That's the velocity of the ball. This is the starting height of the ball. This has to do with gravity, the gravitational constant divided by 2. All right, I didn't really expect you to remember the gravitational constant thing, but the velocity was this one. Okay, so what else do we know about the ball? We know its speed and the height and the time. That's it. We don't know anything else. do you get in the real world, oftentimes there's more than one thing you could know. For example, let's say that I have a ball. I do. Unless somebody's. Oh, there it is. Okay, so I have a ball in my hand. You can't see this on the video, but. And would you agree that this ball is some distance away from you right this second? But if I said it's about 3 feet above your head right now, I think that's true for everybody. But it's a different distance away from you, like x-wise. Like laterally, like if I had to walk to you, that would be the x, and then the y is the how high it is. So most of your heads are at about here, okay? So now this is about 3 feet above your head. I'm holding the ball up in front of the whole room, okay? So if this ball has two components, it's how high it is, like if you had to get to it from your eyeballs to here, you're probably just gonna look at it directly, that'd be like the hypotenuse, but it's gonna have two components. You're gonna go over and then up. So if I had to get to Jake, I'd have to start at him, I go over and then up. There's an x and a y component to where the ball is. Plus, it's there at a certain time. So if I start at time 0 here, and then I go, okay, now I'm here, and now I'm moving the ball over here, and now I'm moving the ball over there, you need to track 3 things. What time it started, and the x, as far as how far away it is from you, in the x direction, and then y, which is the up and down direction, and then so there's 3 things. How in the heck are we going to graph something that has 3 things? Because this only had 2. Well, it's with parametrics. So with parametrics, you can have a graph that starts here at time equals 0. Let's say this is the ball, and this is, let's say you are at this spot because your head's off the ground in the first place, right? Okay, and then the ball goes up even higher, but it's closer to you at time 2. So this was at time equals 0, and here's time equals, let's say after 2 seconds I got it to here. And then let's say I lower the ball right down to your head height, but do you get it still not right at your head because it's still laterally x distance as away from your head, but it's at head level? That's like this. I've got it down to head level, but it's further away from you x-wise. Okay, so that's at t equals 3. Would you agree that in normal graphing we can't go backwards, but couldn't I go back to where I started from and put the ball here at time equals 4, right where it was exactly the same as where it was at time equals 0? So we can do cool things with this that we couldn't do before. We can, it doesn't pass a vertical line test anymore. You can be in 2 places at once. But it used to be time was down here, but it's not. Time won't be down there anymore. Time will be labeled on the graph. And that saves room. We can have this be x distance, which is like lateral distance away from you, like the distance across the ground, you might say. And then this can be the y, which is the height that the ball is at. And we can have 3 things. At this spot, I know it's x, I know it's y. Its x is this, its y is this, and I know it's time because it's labeled with the time on it. That's what parametrics are like. They have 3 things instead of 2. All right, now let's look at one. Everybody go to this page. Now, I really wish they hadn't put f in there because it looks like it's a whole nother variable. But you remember when we said f of x, f wasn't really a variable. It was just saying it was the f function. So in the f function, we have x and t. In the y function, we have y and t. Sorry, that's the g function. This one was the g function. This was the f function. So there's really only 3 variables, x and y and t. And they're just labeling, hey, this one's f of x. Sorry, I was trying to highlight. This one's f of x. This one's g of x. 3 variables. But look at it. It doesn't have to follow the order of operation. Sorry. It doesn't have to follow the, what's that called again? The vertical, what? Vertical line test. So these are not really functions. All right. So let's get to another page. So this one. Here's your first parametric. And how would you know that it wasn't just a normal XY chart? Because look, it's got t and x and y. It's got 3 variables. See? T equals -2, and then there'll be an x, and then there'll be a y. I'd like you all to put -2 in to this equation. Put -2 in right here. T is -2. T is -2. And see what you get for x and y. Compare it with your partner. Make sure you guys get the same thing. Pause for a second while you stick in -2. All right, so did you get -5 for one of your numbers? I'm going to go with, in the back row, Zodi. What did you get for this one?
X was -5, and Y was also -5.
Raise your hand if you had -5, -5. Awesome. Now, would you finish and get me all the rest of the points and graph them? Just don't try to graph T. Hint, don't graph the T. This is X, this is Y, and everybody knows where -5 is. You just have to count it out. But when you graph it, we'll have you put in a little tiny next to it, T equals -2. That's how you graph the T. You just say, hey, by the way, at that point, T was -2. Do that for each of the points, okay? So get each point and then tell its time next to it. I'll pause for a second while you graph those. Okay. I'm going to put in what I think they are, and you guys can check yours. -4, -3, just to make sure I'm on the right track. Raise your hand if you guys had that same point. Okay, good. Then I'll put in the rest, -3, -1, and -2, (1). And then I'll get some people to help. Cal, what was the next one for 2? When you stuck in 2, you got?
-1, 3.
And the last 2?
0, 5, and 1, 7.
You guys concur? Okay, good. All right, then, if I graph them next to each point that I graph, -4, -3, 1, 2, 3, 4, -1, 2, 3. At each point, I got to say what it is for T. T equals -1. I encourage you to write your T like with a little tail at the bottom like this, because otherwise it looks like a plus sign. And it sort of looks like an X also without that little tail at the bottom. So I'd write your T's that way, but I'm not going to mark it wrong unless I can't read it. So, all right, next up, -3, -1. And do you get the pattern? It looks like it's going in a straight line to me. Okay, so I'm going to jump right to the end. 1, 7. Why am I doing that? Because, 0, 5 actually, because that's the last point I can graph. And that'll be in a straight line, and I can kind of skip the middleman. And it does go to 7, so it stops at like right about there-ish. It's off the graph, but. And this is an important point. It moves in that direction. You see how I put a little bunch of arrows in the middle? Okay. These are directional, as in it starts here and it ends there. All right. So, is that it? It's just TXY, and you graph these things, and they're like lines, except they have a start spot and an end spot, and you number it along the way. That's kind of it, but there's one more skill I got to teach you. And that is, isn't there some other way to, just with the old system of graphing, couldn't we have made a straight line? Like y equals, let's see, it's went through 0, 5, so it was up 5. So it'd be like y equals 2x plus 5. Do you get that that's the same as y equals 2x plus 5? Kind of. It's got a slope of 2, rises 2, runs 1. Okay, but what's different about it than that? It says a starting spot and an ending spot. It doesn't just go forever. See, this one goes forever. All right, so I'm going to teach you how to convert this into one of these rectangulars. And so like right above it here, I'm going to show you how to convert this. Convert. Does that sound familiar? Didn't we convert from polar to rectangular before? You remember doing that last test? Stuff had r's and thetas, and we changed it over to x's and y's. Okay, well, what does this have? X's and y's and t. And notice this little limiter over here. T had to be bigger than or equal to -2. That's why they started with -2 and then they went this way, because they got bigger than -2 each time. It was kind of subtle. We never really talked about that, but that's true. That's not polar. What's that? The new unit's called what? Parametric. This was a parametric. But that is rectangular. I'm going to show you how to get the one into the other. How do I get this transformed? Everybody take this one right here and solve it for t. What's t equal to? Break out of your trance. Solve this for t. Compare with the kid next to you. What's t equal to? You guys get x plus 3? Okay, good. Now solve this one also for t. I'm adding 1 to both sides. And then, I just have to divide by 2 to get t alone. So I'm going to go y plus 1 over 2. You get how I did that? Okay. Then, I'm trying to get this to just be x's and y's and no t's anymore. Somebody sees it. Figure out how to get this to be just x's and y's. All right. Did you realize that you could put that there because t is x plus 3. So this t right here could be x plus 3. And then you have x plus 3 equals y plus 1 over 2. There. The only thing wrong with that is that if you graphed it, it would go forever in both directions. Think about that. Don't normal lines, straight lines, they just keep going forever. How do we get it to start and stop? Well, look at where it started and stopped in the first place. But we don't have a t anymore, so we can't say it was from -2 to whatever. Yes?
Does it stop?
Good question.
Because it just says that t is greater than -2.
You are correct.
That it's less than -2.
Most of the problems you will have a start and a stop, but you got me. This one does not stop. This one starts, though, at -2, and it never stops going in that direction. So what we do is we replace, and because we can't talk about t anymore because we're changing this. It's no longer, Cal, could you shut the door over there, please? It's no longer in parametric, so it doesn't have a t anymore, but it does have an x. What could you say about x? You wouldn't just change it to, x is greater than -2. No, that wouldn't make any sense. Look at it. Tody.
Well, x is greater than or equal to -5.
You got it. So I put this, I should have put this down here. So I will. X has to be greater than or equal to -5. That completes the puzzle, but it still lost one thing. It is a straight line that would start at -5, but it no longer has t, so it no longer has the time component. Do you get, we don't know when it started? Well, we could kind of assume, no, or could we assume? We don't know which direction it is. If I just told you this, you wouldn't ever really know what time it started. All right, you might be able to make an assumption that t was 0 at that moment, but you'd have thought it was 0, not -2. How would you have known that a time was -2? So, moral of the story, this is not exactly the same. See, before, when you did polar and rectangular, they were exactly the same. This isn't exactly the same because we lost a variable. It doesn't have t anymore. So this is just rectangular. All right, let me give you one. X plus y equals 7. Is that rectangular or polar or parametric? Which one is it? That's just rectangular. T equals 4x plus y. What's that? That looks like parametric because it's got 3 variables. Okay, but the way you can really tell something's parametric is at the end, they'll say, like, let's say t equals 4x, and let's say t equals 6y minus 7. And then they'll say, oh yeah, t has to be between 0 and 1. If they give you a limiter on your t, then you know that's parametric. And it's got the times. It goes between 0 and 1. It starts at 0. It stops at 1. And you could figure out from a TXY chart where it starts. Would everybody just figure out where it starts? From the TXY chart, where does this graph start? Compare with your partner and see if you agree on where would this graph start. At time is 0, so you stick a 0 here, and you stick a 0 here. And can I solve that for x, and can I solve it for y? So at time was 0, I got, I'm going to divide both sides by 4. 0 divided by 4 bothers people sometimes because they're like, it's impossible. No, 0 divided by 4 is just 0. So at time 0, x was 0. And y was, well, let's solve this one. And I'm going to add 7 to both sides. 7 equals 6y. Divided by 6, divided by 6. And y equals 7, 6. Raise your hand if you had it right. Cool, that's a point. At this point and this time, you could graph that. Go over 0 and up 7, 6. I'll just say that that's at 7, 6, and it's at time equals 0. And that's where the graph would start. And then you could make another point for it where t was 1. Would everybody please stick in 1? If t is 1, can you solve it? If I stick in t equals 1, there's a 1 here, and there's a 1 here. So x would equal 1/4, and y would equal 7/6 again. Is that possible? Double checking myself. Oh, no, not quite 6. Had 7 was 8/6. There we go. Who had 8/6? Good job. You beat me. All right. And then if I graphed, do you get it starts here and it ends there? And if I asked you to trade this one out, this would be super simple to trade out because I already got them solved for t, see? Tell me this in rectangular then. Write the equation for it in rectangular. Did you say 4x equals 6y minus 7? Raise your hand if you're right. Cool. But there's something else. Who knows the rest of the rectangular? Because otherwise, this would be a line that goes forever and never stops. Is that what we had? No, we had a start and a stop. Zodi, what do you want to add to this to make it an actually right answer?
You add, well, x is greater,
I'm going to go like this. I'm going to make a sandwich.
well, yeah.
This is the easy way to do it. But I know what you meant. And what's on the left side and what's on the right side?
On the left side is 0, and on the right side is whatever 4.
Got it. Why can't we just say t's between 0 and 1 again? Because that would be parametric. Okay, so this is your final answer, unless you see something wrong with it. Yes?
Just curious, do polar parametric equations exist?
If they do, I don't know how they would work. I believe they very likely could because
Because it's like, well, like instead of solving for x and y, you could solve for r and theta.
I think I hear you. You're the first person that has asked me that. And I don't know. It could be a college like, I could see a college going into something like that. We don't. All right, so there we have a rectangular, and there we had a parametric. Sorry, this one was the parametric. It's getting kind of messy. I'd like you to this page, and without my help, I'd like you to change this parametric into a rectangular. Act like it's a test question and that you have a partner. Good luck. Okay, I got reminded that we had just done one just like this. I'm sorry. All right, so just a reminder, you would have solved this for t, solved that for t, and then set them equal to each other. And yeah, you're right. I recognize that t is greater than or equal to -2. Sorry about that. We'll do a different one. We'll start on the homework. And this one, don't graph it, just convert it to non-parametric form. I'm going to say that that's rectangular form. So we started with t equals, and you should add x plus 3 over 4. Can anybody verify that? You got the same thing as me? Okay, good. And then this other one, y plus 2 over 6. You with me so far? Okay, then you just have to set the one equal to the other. X plus 3 over 4 equals y plus 2 over 6. And don't overthink this. You don't have to solve it for y or anything. That's it. Except it needs an x limit. X is between what and what? Because this one didn't get to go forever. It only went from time 0 to time 1. Now, last time we just plucked that off the XY chart, the TXY chart. So actually, since you're going to have to graph it anyways, let's make the TXY chart now. TXY. Okay. T is 0 because of that. And I figure out what x and y would be. And then 1. And when you have those numbers for the t and the x and the y, then you'll know what x has to be between. Miss Paul, are you done yet? Okay, what did you, when you put in 0 for your t, what did you get for x and y?
-3 and -2.
-3 and -2. And that pretty quickly tells you the lowest that x could be, which is what? -3. So it went between -3 and the other point, Miss Paul?
1 and 4.
And therefore, did you say less than or equal to 1? Look at that. What's that? That's a rectangular equation that would be exactly the same as the other thing, except it doesn't have time. Do you get, we knew time was between 0 and 1. But this equation, we wouldn't know that. The time might have been between 0 and 1, but the time might have been between 6 and 7. We couldn't tell. We don't know the timing on this one. We know the starts and the stop, but we don't know when it happened. Okay, so we lost some info. I just always want to make it clear. This is not an exact, it's kind of close And it'll make the same picture, but it won't tell us what time it happened. Parametrics are better because they tell you more stuff. So if you actually graph this, then you just have to graph 2 points, that graphs, and then you say what the t is next to it. So -3, -2. I could easily see a kid going, yay, I graphed it, I'm done. Wrong, because you'd have to say t equals 0 and t equals 1 and a direction. It was going that way. Why don't you think I put the arrow on the tip of it? Because that would imply it keeps going in that direction. So you put the arrow in the middle. Different system of numbers. Can't expect it all to be exactly the same. Parametrics are a little different. They have a start and a stop. They have direction. They have 3 things for each point instead of 2. And I hope you feel a little smarter than you were when you walked in. If you don't practice this, you're getting in a really bad habit because you need to do math each night, just a little bit. I try to keep it real reasonable, but I also know that you're faced with like, oh, I got these 6 things to do tonight. And then if you don't have math that you have to do, then you a lot of times won't. So we as a team, the pre-calc team has decided we need to make you step up a little more on homework. So we're going to start collecting homework more often to make you actually get some homework done. Do you have to do all of them? Nope. Nope. Don't have to do all of them. You have to do some of them. Some of them you're already doing it. All I'm asking you to do is start Dropboxing it. So again, do you have to do all the homework problems? No. Do you need to turn in homework? No, I'm not going to put up a box every night, but I'm going to put up a box fairly frequently now for you to turn in homework. Show me that you're doing something. All right, that's all I got for you for today.